Hi, this is Mrs. Wiederholt, and welcome to my lesson video on changing forms of exponential and log functions. Now let's get started. Now take a minute to look at the following functions. Can you figure out how we change from the exponential form to the logarithmic form? Do you see a pattern? Pause this video for just a moment so that you can look and see if you can find a pattern. Now let's look at the first row. We have 3 to the x power equals 9, and then we have log base 3 of 9 equals x. Now, if I look, the base of my exponent, which is 3, becomes the base of my log. The exponent of my exponential function becomes the answer to my log function. And then the answer to my exponential function becomes what we call the argument of our log function. Now let's look at the second row. We have 2 to the x power equals 32, and we have log base 2 of 32 equals x. So here again, the base of my exponential function becomes the base of my log function. The exponent of my exponential function becomes the answer to my log function, and the answer to my exponential function becomes the argument of my log function. Now here's just a little something that might help you with this. Let's look at the first log function again, log base 3 of 9 equals x. We can do something like a little heart. We can say 3 to the x power is equal to 9. So I don't know if that's just something that will help you learn it. Let's look at the next one down. 2 to the x power equals 32. Now let's look at the third one down. 5 to the negative 2 power equals 1 over 25. We could actually do the same thing with the exponential function. We could say that log base 3 of 9 equals x. Let's do the next one down. Log base 2 of 32 equals x. And then let's try the next one down. Log base 5 of 1 over 25 is equal to negative 2. So basically what we're saying is that log base b of a equals x can be changed to b to the x power equals a. Now let's look at some examples. Our first examples are going to be to change log functions to exponential functions. So let's try the little trick that we just did on the page before. We're going to have 3 to the second power is equal to 9. So our base is 3, our exponent is 2, and our answer is 9. Okay, let's try this next one, try b. Now remember, it's the base of the log function, which is 10, is going to be the base of our exponential function. The answer to our log function is going to be the exponent of our exponential function. And the fraction here, this right here, the argument to our log function is the answer to our exponential function. So that would be to equal to 1 over 100. And if we wanted to draw our little heart, it would look like this. Okay? Now let's try c. Our base is 2, so it's going to be 2 to the x power, and that is going to be equal to 64. So again, our base is 2. The answer to our log function is the exponent of our exponential function, and the argument of our log function is the answer to our exponential function. Remember, you can pause this video at any time so that you can spend a little more time on each problem to fully understand. Please don't think you have to move as fast as the video seems to move. Please pause it at any time. Now, let's go ahead and move on to the next set of examples. Okay, now we're going to change an exponential function into a logarithmic function. Now again, we can use the same little trick that we did last time. Let's look at A first. We're going to say, and I'll go ahead and write log down because this will be a log. So log base 5 of 125 is equal to 3. So now let's write that. Log base 5 of 125 is equal to 3. Now let's look at example B. We have log base 3 of 81 is equal to 4. So we would write it like this. I'm going to move down here and write it. Log base 3 of 81 equals 4. Now let's do example C. We will have log base 6 of 216 is equal to 3. So when we write it, it will look like this. Log base 6 of 216 is equal to 3. Now let's look at solving some log functions. When we need to solve a log function that looks like these three examples, basically we're just changing its form to the exponential function, and then we're able to use our calculator if needed to solve for x. So let's do example A. We will rewrite log base 8 of x equals 4/3 and as an exponential function. So it will be 8 to the 4/3 power is equal to x. So let me write that. 8 to the 4/3 power is equal to x. Now at this point, all you need to do if you have a TI-84 graphing calculator is you can put 8 to the 4/3 power in your calculator. And most of them you need to do 8 caret top and then in parentheses put 4 divided by 3 and then press enter. And when you do that, you will get x equals 16. Now let's look at example B. We have log base 27 of x equals 2/3. So I'm going to rewrite that as my exponential function. So that will be, my base is 27, and that will be to the 2/3 power, and it will be equal to x. Now again, just put 27 to the 2/3 power in your calculator, and you will get x equals 9. Now let's look at the third example. We will have 4 to the 2/3 power, to the 3/2 power is equal to x. So I will write that as 4 to the 3/2 power is equal to x. Put this in your calculator and x equals 8. Now let's move on to our last set of examples. In these examples, we are going to evaluate these log expressions. If you are using the TI calculator for this, TI calculators operate using a base of 10. So for all log functions, if you were to just see log of 10, log of 0.75, log of 1/100, we would assume, not really assume, but we can know that those are in the base 10. Now, whenever we have log functions or log expressions that have a different base other than 10, well, that's when we actually see the base there. Now, if we want to evaluate this in our calculator, we are going to have to basically do what is called finding the common log. And that is, we are going to divide the log of the argument by the log of the base. And when doing so, the calculator will interpret that as in log base 10. So let's now do example A, and I think you'll catch on to this real quickly. Now, I have to take the log of the argument. Now remember, this is the argument, and this little subscript number is the base. So I have to take the log of the argument, which is log of 10, and I'm going to divide it by the log of the base. And that's all you do. You just write that as a fraction, and you can enter that in your TI calculator, log 10 divided by log 5. And when you do that, your answer is 1.43. Now let's try example B. I will take the log of 0.75 divided by the log of 9/16. Now remember, in your calculator you need to write that fraction or put that fraction in parentheses. And then all you have to do is press enter after you put that in, and your answer is 0.5. Now let's go on and look at example C. I will take the log of 1 and divide it by, I said the log of 1, I meant the log of 1 over 100, and divide it by the log of 100. Remember, I'm taking the log of the argument divided by the log of the base. And my answer to this one is -1. Now, I hope this lesson video has helped you understand changing forms of log and exponential functions just a little bit, and I look forward to working with you again. Bye-bye.